Hello, stats students. Welcome and good morning. So today what I thought I would do is start us out by doing one of the practice problems that we had for homework. I figured I'd do problem number 6-9, and that covers most of the ideas of section 9.3. There's more stuff we're going to do. That's why you're going to have another assignment tonight. So to get to this question, it says, attitudes. In the study of older students' attitudes from exercise 65, the sample mean SSHA score was 125.7 and the sample standard deviation was 29.8. So I've gone ahead and written that on the board here already, and I can tell that you can barely see that. So let's fix that. There we go. So you should be able to see that a lot better now. So 125.7 is the sample mean, and 29.8 is the sample standard deviation. If we go back to question 65, they tell us that the survey of study habits and attitudes is a psychological test that measures students' attitudes towards school and study habits. Scores range from 0 to 200. Higher scores indicate more positive attitudes. The mean score for U.S. college students is about 115. So I put mu as 115, the actual mean. Okay, so that's for U.S. students. A teacher suspects that older students have better attitudes towards school. She gives her SSHA to a simple random sample of 45 of the over 1,000 students at her college who are at least 30 years of age. Check the conditions for carrying out a significance test of the teacher's suspicion. So we should have already done this one, but we might as well because we would need to do this for our question. So the sample size, I added that in, is also, that was 45. So first thing, quantitative or qualitative? Yeah, that's quantitative. We're talking about a number, not a quality. So we've got quantitative data, so we're dealing with means. So next thing, was it a random sample? Yes, it was. She said it was a SRS, so it was a simple random sample of the 45 of her 1,000 college students. So the next thing we could do is 10%. So first of all, random, check, SRS. Second, 10%. So is 45 less than 10% of 1,000? Yes. 45 is less than 10% of 1,000. Check. What was the third one? Large enough. Is our sample size greater than 30? Or if not, are there no outliers and not major skew? Is it normal? Well, our sample size was 45, so n is greater than 30, or equal to, because n equals 45. Check. Okay, so yes, we are allowed to do this. Okay, so the next thing we want to do is we want to think about, well, what's our test statistic? Because I believe that was our first question, part A. Part A asks, yes, calculate the test statistic. So that's basically like our z-score, but remember for means, when we don't know the standard deviation, that's a t-score. So we're going to solve, let's change color here. We're going to solve for t. So just like z, t is the data value of interest minus the mean divided by the standard deviation of the sample. So our data value is 125.7, that's the one of interest, minus the mean, 115, divided by the standard deviation of the sample. Now remember, this is means, so we would do sigma divided by square root of n. But we don't know the standard deviation of the population, so we have to use standard deviation of the sample, and that's why we have to stick with t's and the t-table. So what is our standard deviation of the sample? 29.8 divided by the square root of our sample size, square root of 45. So ultimately, let's get rid of that. We put this in our calculator, and we get approximately there it is, 2.4086. So our t-table goes to 3 decimal places. So let's round this to 3 decimal places, 2.409. Let's put that down, 2.409. 0.409. So it's like a z-score on the z-table. It's like how many standard deviations away from the mean you are, but this is a t-score on the t-table. So it's a little different. So there's our answer to part A. Now part B, here we're going to actually figure it out now. We're going to finish the problem. So now what we've got to do is take that test statistic t, and let's use our t-table to figure out what's the probability of getting a value of 125.7 if 115 truly is the mean. That's the idea here. So let's change color again. So gosh, let's see. So we're going to have to look at the table, right? So we need to know degrees of freedom. Remember, that's our sample size minus 1. So we've got 44 degrees of freedom. So we'll use that exact number later in our calculator when we do it with tech. But for right now, we've got to use the table. Let me find the table right quick. The t-table is this one. So what you're going to do on the left-hand side is go down to 44 degrees of freedom. However, when you do, you're going to notice 44 isn't there. Starting at 30, it starts to skip. Remember that? So we do the lower degrees of freedom, which is the larger value in here. So it makes sure it captures our value we're looking for. So instead of 44 in our table, we're going to use 40 degrees of freedom. So I'm going to say approximately 40 degrees of freedom. Now, when we use our calculator, 44 was more accurate, and that's what we'll use. So, but with 40, now what we do in the table is at 40, go across the table until you see the two values that surround our t-value. So if you look for that, you'll find that along 40, if you go all the way over to 2.123, 2.123, and then on the other side, 2.423. That's above, that one's below our 2.409, right? So here are the two t-values that the table contains our t-value. So what you do then, go up to see the percentages on both sides of that. So when we go up, we're going to see this is 0.02 and this is 0.01. So that means our p-value, or our probability value, if you will, is going to be between those two. So it's between 1% and 2%. So if we think about that, 1% and 2%, if our alpha level was at 5%, which it typically is, that's our usual alpha level. If it's less than 5%, we don't buy it, so we reject the null. In this case, between 1 and 2% is less than 5%, so we are going to reject the null hypothesis. So we have found convincing evidence that the null hypothesis is probably not true. So what they're saying is for older college students, the mean happiness score there probably isn't 115. It's probably different. Okay. Now, with our calculator, here's what we're going to do. We are going to change color again, and we're going to use the more accurate 44 degrees of freedom. And the way we're going to do that is we're going to go to, in your calculator, go to distributions, second dist, right? So, second dist. And then what you're going to go to is you're going to go to number 6. Sorry, no, number 5. Nope, number 6. Sorry, TCDF. TCDF. That's a T cumulative density formula. It was we did that earlier with our Z stuff way back in the beginning of the year, something very similar to this. What this is doing is finding the percentage from your T value below. Instead of a Z value, it's a T value, right? So we go to that, we're going to go ahead and hit enter. And from there, with the new operating system, it asks you what to do. if you don't have the new operating system, you're going to need to remember what to put in, the 3 items, the lower, the upper, and the degrees of freedom. But for us, it's going to ask us lower, upper, and degrees of freedom. So what you're going to place in there, since we're at positive 2.409, it's going to be from there and above, right? So your lower is 2.409, upper, a large number, 100, 1,000, 10,000. They're all way more than 3, 4, or 5. So, I'm just going to put 1,000. And then what were the degrees of freedom? That's right. We're going to use the more accurate 44 degrees. So we'll put 44 there. So when we do that, hit paste or enter, and we end up with our final answer of 0.0101247, blah, 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 blah. So in other words, 1.01% approximately. So it's approximately a 1.1%. So is that between 1% and 2%? Yeah, it is. Notice how much closer it is to this one. Notice our how much closer 2.409 is to 2.423 versus 2.123. So yeah, it looks appropriate. That looks like a good answer. I'm pretty happy with that. Okay, so, you guys want to get a joke for the day, huh? So the homework tonight, I believe, is posted, but I can go ahead and tell you what it is here as well. It's to complete the Barron's AP questions 1 through 23. I've attached those in Teams, so you can either print that out and then write on it and answer it all up, and then take a picture of it or a scan or anyway, and then re-upload it back into Teams under that assignment by, the 24th, Tuesday night. So I'm giving you guys all the way until 11:59 of that evening. So you have all day, and you can ask questions that morning if you need to as well. That's the idea there. But this will be 2 days later. So this is the assignment that you're going to be working on for the next 2 days, as well as, nope, I scratched that. I'm only having you do these parts. So I also have added 3 links in the Teams assignment as well, videos on YouTube to go watch. Please go watch those as well, because I think those are going to be really helpful. And that kind of writing tablet, I just got in the mail today, so pretty soon you're not going to have to look at this ugly mug. I'll be able to just put it on the board directly to your screen, so you guys will be able to find the answers or hear the examples that way. Okay? I'll still bring in some guest speakers, though, I promise. Anyway, let's see. Have a good time. Oh, your popsicle joke. How can we forget the popsicle joke, right? Gotta have the popsicle joke. Okay, what is it? Why did the song do so well in school? Why did the song do so well in school? It took a lot of notes. You see what I did there? It took a lot of notes. Talk to you later. See you in Teams.